Hello, my name is Ghezal, and I'm a cloud operations engineer at Comcast. Today, my talk is going to be about OpenStack Operations at Comcast. First, I'm going to tell you about what Comcast offers and who we support. We support internal engineers that run their internal applications on our cloud. The Comcast Cloud Infrastructure services enable you to run your applications on a private cloud. Our key hardware resources are Nova, Compute, and networking. They are all pulled together to provide maximum elasticity and flexibility. Some of the responsibilities of the operations team. We support customers and troubleshooting. We support customers through Jira tickets, phone calls, live chat, and emails. Tenant requests, onboarding, and customer consultation. When a new tenant is created, we provide a welcome letter to each user in that tenant. The welcome letter contains basic information about OpenStack, some of our wiki pages, FAQ pages, some of the best security practices used, networking information, etc. We're also responsible for environmental deployments, upgrades, monitoring and evaluation, hardware troubleshooting and replacement. We work with the hardware service desk to get our hardware replacements done. We're also responsible for maintenances, capacity planning, last but not least, contributing back to OpenStack. How we manage Quota. We manage Quota by monitoring the capacity report. The capacity report talks directly with the databases on each controller within each region. It gathers information about IP address usage, quota information, VMs currently running alongside their flavor size. All large quota asks needs to be approved. An example of a large quota ask is hundreds of cores, RAMs and storage being multiple terabytes, and vast numbers of extra large instances. We overcommit each environment by 115%, and once an environment reaches 70%, we close out that environment. Monitoring and escalation. The cloud has a lot of moving parts, and monitoring is complex. We use Raken, a Nagios-based monitoring system, to monitor our cloud infrastructure. Here at Comcast, we use 24/7 eyes on glass when it comes to monitoring. We use CNOC for this monitoring. The on-call will get paged out when there is an incident. However, we never get paged out for a single VM or even a single compute node that goes down. Here's a little diagram of where we would like to be in the near future in terms of monitoring. Our environments. We currently run both Havana and Icehouse environments on our cloud infrastructure. Previous to Havana, we ran Essex. Some of the benefits we see moving away from Essex is that stuff generally works a lot better. In our Essex environments, customers were not able to restart or reboot their instances from the dashboard. However, we had to go in and do it through the controller nodes. Some of the benefits we see in Havana is that you can assign multiple NICs to your instances and have private networks for your instances to use. In the Havana release, previous to Havana, console VNC was not sent over HTTPS. This caused a lot of issues with web browsers, and this issue has been resolved, and the Havana release and console VNC is sent over HTTPS. Moving on to Icehouse. One of the great benefits we see in Icehouse from an operational standpoint is rolling upgrades. It is now possible to upgrade your systems without having to nuke and pave and without requesting downtime for users. Another great benefit we see in the Icehouse region is in our Icehouse region, we introduced a new storage cluster alongside our Ceph cluster. This storage cluster is composed entirely of SSDs. Some of our challenges. Maintaining documentation can be challenging because when we have new upgrades or release a new environment, we have to update all these documentation. Sometimes our users do not read the documentation and come to us with the same questions that is provided in the documentation. Customers that have a pets versus cattle mindset. This is challenging because customers that have this mindset worry too much about a single VM that goes down. Hardware. Hardware can be challenging because we work with vendors and with the hardware service desk to get our hardware issues resolved. Working with the vendors, they request logs and screenshots of the issues before they even accept the fact that there's an issue with the host. This can be very time-consuming. Learning to live without stable IPs. Carrying custom code and being 3 releases behind on OpenStack is quite challenging. We are missing out on a lot of new services and new features that the newer releases can offer. Customer demands and maintaining 2 different releases can also be challenging. Our goals in the near future. Heat. We would like to supplement Heat into our OpenStack infrastructure. For those of you who do not know Heat, Heat is an orchestration service in OpenStack. This allows users to define and automate their cloud applications. From a user standpoint, you'll be able to deploy your internal applications across multiple networks. Load balancing as a service. We are working on providing load balancing as a service to our cloud infrastructure. This service spreads incoming traffic across multiple nodes. Last but not least, Sweeper. Sweeper is a tool developed internally. If you guys are familiar with JanitorMonkey and AWS, it pretty much does the same thing. Sweeper will help the operations team by automatically finding instances which are idle. Sweeper will send out a notification to the user and to the tenant, letting them know that their instances are idle and they need to take action. Using Sweeper, we hope to reclaim lost resources. We will be able to assign those lost resources to new users or increase quota for existing users. And that is all. Thank you.